Hey everybody, this is Miss Kent. This is week 3, day 2, number talk. Today we're going to be talking about a skill, and I'm not going to tell you what the skill is to start with. I want to see what strategy you decide to use as we solve this problem. Our first equation today is going to be 8 times 3. Okay, now I want you to stop the video and I want you to solve this mentally, and I want you to think, what is the best strategy to use here? Consider all the strategies that we've learned so far through our number talks. Okay, most of you got the answer of 24. Think to yourself, how did you get that answer? What did you do? If you use that strategy of skip counting, 3, 6, 9, 12, 15, 18, 21, 24. Now that is a strategy we started out with, but that strategy is not so efficient now. And it's really not going to be efficient next year when you get to 3rd grade and then to 4th grade, because the numbers are going to get larger and you're not going to be able to count by threes that high. But I do know some other strategies I have worked with, okay? What about, inside that 8, there's a 5 and a 3. So I might say 5 times 3 plus 3 times 3, okay? 5 times 3 is 15, 3 times 3 is 9. Oh man, this one's kind of hard for me to add. I have to start thinking about regrouping. That'd be 14, 10, 24. I really didn't like that strategy either. That wasn't very efficient. So I'm trying to get that camera just right. Now, if you think back to when we were in school, one of our partner math assignments had a very efficient strategy that we were working toward. We hadn't gotten there yet. And that strategy was called doubling and halving. So when we're multiplying, if we half one number, half of 8 is 4, then we're going to double the other number. And if we double 3, we get 6. Hey, this is a lot easier because you know what? I know if I double 6, I get 12. And I double 6, 6 and 6. 4 is a double-double. So if I get to the 12, if I double 12, I get to 24. So 6 times 4 is 24. So kind of in my head, I was thinking 6 times 2 is 12. And then when I double 12, 6 times 2 again is another 12. That's 24. Halving and doubling. Now I want to look at this problem very quickly. Could I have halved the 3 or halved the 3? Cut it in half. Technically I could have, and this is what my problem would look like. I'd have to double the 9. So that would become, double the 8, and that would become 16 times 1.5. Are we multiplying by decimals yet? No, we're not. So I have to look at which number can I half and which number can I double. But when I look at that, I also want to look at which one's going to be more efficient. And efficient here kind of means which one's easier for me to solve, which one do I have the best strategy for. So let's look at another one. 4 times 6. 4 times 6. So stop now and solve it, or you might know this one really quickly. 4 times 6 is 24. How did you know 4 times 6 is 24? Did anybody say, hey, that is exactly the same as 8 times 3? 4 times 6 equals 24, and 8 times 3 equals 24. Do you remember that we used that 4 times 6 because we half the 8 and we doubled the 3? Okay, so let's look at this one. Four times 3. Stop the video if you need to and come up with your answer. Okay, a lot of you probably wanted to say 4 times 3. 4, 8, 12. Or maybe you said 3, 6, 9, 12. Is that the most efficient way? No. And when I'm talking about skip counting, you're jumping on a number line by 3s or by 4s, okay? What about that doubling and halving? Which number up here could I half easily? The 4. Half of 4 would be 2. If I half the 4, I have to double the 3. And if I double 3, I get 6. 2 times 6 is 12. Now, I do want to demonstrate this on a number line for you so you can kind of see where it applies. I'm going to draw my number line. It's going to start with 0. And in this case, I'm going to count by 3s. 4 times 3, 6, 9, 12. Okay, so I counted by 3s 4 times. And you see I had to make 4 jumps. Not as efficient. The more steps, the more likely you are to make a mistake. Hey, why don't I jump by 6s 2 times? I'm going to go underneath here so you can see. 6, 12. How many jumps did I make? Which one's more efficient? 2 times 6 is more efficient than 4 times 3. Fewer steps means you're less likely to make a mistake. Okay, let's look at another one today. Now, I know you're going to say, oh, that's easy, Miss Ken. I know the answer to that one. But I want you to think of this one and apply today's strategy to it. How would you solve this one applying the strategy of doubling and halving? I want you to stop, and I want you to come up with what your equation would be if you doubled and halved this problem. Of course, this is the identity property where 1 multiplied by anything is the other number. So we know this answer is going to be 12. But let's look. Can I half 1? No, then I'm going to have to do what? Double it. If I double one number, I'm going to have to do what to the other? Half the other number. I'm going to build onto this, and I want you to kind of see how this problem progresses and builds. Now look at these equations. What do they have in common? The first thing they have in common is they have the same answer of 12. What else do they have in common? 3, 6, 12. I'm doubling. 4, 2, 1. I'm halving. Now let's look at these equations on a number line. I'm going to use some color coding here to help you see. Okay, so here's my number line. 1 times 12. 1 times 12 is 12. How many jumps did I make? Less likely to make a mistake there. 2 times 6. 2 times 6. Excuse me, I need to start with a 0 there. I don't know why. I just want to put a 1. I want to start with that 1. Okay. 2 times 6. Let's look at this. 6, 12. How many jumps did I have to make? 2. 1. If I double 1, I get 2. Okay. Now let's look at this last one. 4 times 3. 3, 6, 9, 12. How many times did I have to jump? 4. There is a greater likelihood of making a mistake because I have more steps. Okay? So, if you don't know what 4 times 3 is, most of us know how to double because we know how to multiply anything by 2. 3. That one's going to be halved because I'm going to cut that one in half because I can't half that one. 3, 6, double 6 and I get 12. Wow. Let's try one more over to the side and see if this works. Let's see. What about 4 times 6? Okay, I'm going to half this one. I like that 4 cutting it in half because I know half of 4 is 2 and half of 2 is 1. 6 doubled is 12. 12 doubled is 24. 2 times 12 is 24. 6 times 2 is 24. Wow, I got my answer just by continuing to double. Let's do one more so we can see the pattern. Trying to think of a good one here. I'm trying to think of one with larger numbers and it's not coming to me yet. I'm wanting to stick with that 4, but I really don't want to. What if we do 8 times 6? Well, I know if I cut 6 in half one time, I'm going to get 3. I'm not going to get that 6 down to that 1 because I can't half a 3. So let's cut 8 in half and you get 4. If I cut 8 in half again, I get 2. If I cut 2 in half, I get 1. So if I double 6, I get 12. If I double 12, I get 24. If I double 24, I get 48. 8 times 6 is 48. Wow. That's a very efficient strategy. Now, at the end of this, I want to quickly go over one fraction skill because I try to make these videos less than 15 minutes so I can hold your attention, and I didn't get to go over this fraction skill last time. So, if we have 2 of the same shapes, these are supposed to be identical shapes, identical pieces, and both of them have this portion shaded. Okay? What portion of this fraction is shaded? Half. Okay? What portion of this fraction is shaded? 2/4. Is 2/4 equivalent to 1/2? Yes. These holes stayed the same, meaning this one square was the whole, okay? Now I'm going to have 2 circles. And once again, these circles are supposed to be the same size. Okay, so for this circle, what's the fraction? It is 1/2 because the whole is the circle. Now this is what's going to confuse some of you because it is a little tricky. Over here, I have 2 holes. What do I mean by I have 2 holes? Well, I have 2 holes, and each piece represents 1 hole. So I'm going to just draw a quick picture smaller. Here's a hole. Here's a hole. When I put them together, I get 2. So what fraction of this hole does this represent? Well, here, this fraction represents 1. Okay? Why does it represent 1? Over here, the whole is the circle. When I talked about this shape, I talked about this being a hole and this being a hole. Even though these are the same size pieces, this is 1/2 of this hole. This is a whole of this hole. Okay? This is hard for us to think about, but when we're talking about fractions of a shape, we have to start out thinking about what is the whole. What is the whole that puts it together? What is the whole here? Okay? And I will see you for the math lesson for week 3, day 2. Have a great day.